path of definite integral from A to B f of z dz can be along any curve. From z equals A to z equals B. We know that z is given by x plus iy. Therefore, dz will be dx plus I times dy. And if this is the case, then we have the following two cases. Dz will be equal to dx if y is 0. Because if y is 0, then dy will also be equal to 0. Similarly, dz will be equal to I dy if x is equal to 0. In case the initial point and final point coincide, so that C is a closed curve, then this integral is called contour integral. Denoted by, here's the symbol for contour integral, f of z dz. And look at the connection between complex and real line integral. Connection between complex If you have a comment, you just unmute your mic and speak up.
Excuse, are you going to send us the notes?
What do you mean? You're supposed to be taking notes.
You're too fast.
I told you guys you can always check on my speed. If you've not captured something, you just ask me to scroll back so that you can capture all the information that you need to.
Can we start from page 1?
So you guys can guide me. If you're done with copying, you ask me to scroll down.
Done. Done. Done.
Excuse me, we can see presentation.
Sorry?
Okay, I was saying like we can't see the presentation now. System has been restored. Yeah.
Okay. Are we at par?
Yeah.
Yes, we can continue.
Connection between complex and real line integral. Suppose that a single valued function f of z is defined and continuous. So the contour integral f of z dz reduces to calculating the ordinary line integral u dx minus v dy plus I times the integral of v dx plus u dy. You don't have to cram the formula. This is how you arrive at it. So maybe you can say justification. You want to evaluate the integral f of z dz. But we know that f of z is the function u plus I times v. We also know that z, maybe we should have started from z, is x plus iy. F of z is u plus iv. Z being equal to x plus iy implies dz is dx plus I times dy. So the product f of z times dz will be the product u plus iv times dx plus I dy. We expand this, so you'll have u into dx plus I dy plus iv into dx plus I dy. This is u dx plus iu dy plus iv dx plus I squared v dy, but we have the property I squared is -1, so we have a minus v dy. Collect together the real terms, you get u dx minus v dy. The imaginary part, you have I into u dy plus v dx. So the antiderivative of f of z dz is equal to evaluating this integral u dx minus v dy plus I times this integral u dy plus v dx. Look at some properties. You can let me know in case there's an issue with my screen. You know, I can't tell. So you guys were able to see whether it's still okay, or maybe if there's an issue. Can always keep me in check.
Excuse, please. Let us copy the last line.
Where exactly? Because we were just trying to justify the formula for integrating f of z dz. You already have this formula here. The contour integral f of z dz So I was justifying how to arrive at the u dx minus v dy plus I v dx plus u dy. The z is x plus iy, dz will be dx plus I dy. F of z is u plus iv, so f of z times dz is u plus iv times dx plus I dy. If you open the brackets,
Excuse me. I have a question. Could you please clarify using an illustration what a contour integral is? It's a question I've asked in the chat, but ni kama haijaonekana.
No, I can't see the messages in the chat box. So that's why I'm always advising you guys to just unmute and speak up. We will look at illustrative examples in a few. That's where we are headed. So properties. Properties. This property states that if you interchange your limits, if you're integrating a real valued function from A to B, and then you say you interchange the limits such that you want to evaluate the integral from B to A, then the consequence is that there will be a change in sign. So minus C f of z, treat it as you're changing the limit of integrals. If you were to integrate from A to B, f of z dz, then you want to integrate B to A, f of z dz. This is minus the integral A to B, f of z. It also satisfies the linearity property. You can actually split the integral so that you are having several curves, say C1 through to Cn, so plus antiderivative Cn.
Excuse.
Yes.
Kindly scroll back the previous equation. I was just copying and then into the next.
I think next time we'll just have a physical meeting. If the big boys and girls of the university want to beat me up, Sintani protect. I'll be alone.
It depends. Yeah, I have copied now again. The next.
We can even stop there for the semester. See, we've covered enough content to help you sit for your finals.
Sure.
Apana, you need mnahitaji things to tell your grandchildren, so let's just proceed. You need stories to there used to be this potato. So this means you can split. I can't wait to get into an example. This is just exhausting. Split C to C1 through to Cn. The rest, if you have several functions times some constants, you just factor out constants out of the integral symbol and then do what you got to do. You need to define two things before you give an example. Simply connected region. a region R is said to be simply connected if any simple closed curve lying in that region R can be shrunk to a point without leaving R. Wait, I don't know if you guys are done copying. Just quick to scrolling down. I don't know. A region R is said to be simply connected if any simple closed curve lying in that region R can be shrunk to a point without leaving R. I'm drawing myself. I'm drawing a potato. You draw better potatoes in your notes. If we were to draw any curves inside here, then it would contain only points within R. So if you let, oops, I lost that. Let gamma be a simple closed curve on R. Region R
Excuse me.
Mhm.
Yeah, you've gone so far. You've gone so fast.
From what point?
Just a second. Back to the potato. There's something I wanted to see.
Okay. Mtanionyesha maneno. I'll draw a smaller potato here. You can draw a curve inside.
That's fine. A little bit down.
That was fast. Just a sec. Is that okay?
Yes, yes, yes.
Said to be multiply connected.
You can't see the screen.
We should just make a deal. I show up for physical classes, then you'll protect me. You guys are good students. So even last year you agreed to do a cut on a holiday. 2023 April. On 20th of April, you guys agreed as a class. Your class rep was just like, kindly confirm whether we have our today's class, sir. I may also like to update you on this. As a class, we have agreed to have our cut tomorrow, 25 from 3 to 4:30, regardless of it being declared a public holiday. This was after our class. Our Muslim brothers had agreed to take the cut. Kindly confirm your readiness too, sir. Ama nasema vitu zangu. My brain just likes to, the information that sticks is very relevant. See. Are you guys still interested in knowing whether I'm in your class WhatsApp group ama mmeachana na hii vita mwezi? Our Muslim brothers accepted. They agreed we do the cut regardless of it being. Sasa kama mlikubali kufanya cut na holiday, you guys are good students. Tunaweza, we can try, we can risk having a physical class. We love you. You guys, the lecturer in charge was Mr. trying to share my screen. Mr. DiFrangio. He pronounces, let me. Okay, let me try to share this. Is it green? Let me see. Guesswork IT. No, it's not working. Try again. Do this. Should be good. Are you able to see my screen?
Yes.
The lecturer in charge he pronounces these. Mr. DiFrangio. He pronounces differential as differential. Mmemkumbuka?
You tell him what you are doing here.
Msikuwe na hiyo tabia. Mimi sijasema kitu, differential ni wewe. I only said the verse for the semester is 2 Corinthians. And I've also said you subscribe to his YouTube channel. Sijasema kitu kingine. Nothing much. You guys, msikuwe watiaji bana. Me, I've only said you subscribe to the YouTube channel and read the verse for the semester. Differential ni wewe. We look at a few illustrative examples. I'm still children. Sasa eleweni tu. So what is this so-called contour? Evaluate z squared dz. Sam, ni wewe ndio una update math lecturer na details za nini ama who is it? We are looking for whoever is feeding the math lecturer with information. Tukikupata tutakufinya.
Excuse me, madam.
Yes?
There's some notes that was cut off before you just wrote it.
Had you written the definition of multiply connected region?
No.
No.
I don't know, is it in this page? A region R is said to be multiply connected. This is what you're missing, right?
Yes. You can scroll down.
This is not part of the notes. Hey. Usinikosanishe na my seniors. Evaluate the contour integral for the function f of z is z squared. Along. Actually, C stands for curves, and it can either be a straight line, it can be a parabola, it could be a triangle, it could be a square, it could be anything. So it will be specified in the question. You will be told whether it's a straight line, and if it's a straight line, they can either tell you whether they can either give you the equation of the straight line, or they just give you a set of points because they assume everybody went through Form 2. They were taught how to compute the equation of a straight line given 2 points. So along a straight line from z equals 0 to 3 plus I, part B, along the curve made up of 2 line segments, one from 0 to 3 and another from 3 to 3 plus I. So the starting point is, you need the formula to integrate f of z dz. The formula is u dx minus v dy plus I times v dx plus u dy. Clearly, you need to extract your u and v from the function f of z. So you have to use x plus iy, perform the necessary operations. Our f of z is given as z squared. Let z equals x plus iy. Let z equals x plus iy. our f of z is going to be x plus iy squared. This is x squared minus y squared plus 2x iy. So this tells us our function u is given by x squared minus y squared. Our v is given by 2xy. So you need to feed this into the formula. The integration f of z, or rather z squared dz, will be, we want to integrate u dx. Your u is x squared minus y squared dx, minus integrate v, your v is 2xy dy, plus I times, you can open square brackets because it affects the whole integral, v dx, our v is 2xy dx, plus u dy, our u is x squared minus y squared, this is dy. So this is what we'll have to work with, but first things first, we do not have the limit of integration. That's one of the problems. We need to know the limits of integration. So for part A, we are told along a straight line from 0 to 3 plus I. So we need to find the limit of integration. We need to determine the equation of the straight line from 0 to 3 plus I. Maybe we can start from obtaining the equation of the straight line from 0 to I. Or I would actually advise doing rough sketches. So if this is 0, 0, so 0 to 3 plus I, if this is the point 3, and then let's say I is somewhere here. So the straight line from 0 to 3 plus I is this one. The coordinates at the origin are 0, 0. The coordinates at 3 plus I in terms of x, y are 3 and 1. If we can take you guys back to Form 2, equation of a straight line. It was the third chapter. I'm watching hizo. How to determine or to compute the equation of a straight line? The first thing you need is you need the gradient. Once you get the gradient, this is given by change in y divided by change in x. Once you have the gradient, then to get the equation, you use the gradient. You use a known point xy plus one of the given points. Let's say x naught, y naught. So if you're given, for instance, okay, this is not part of the notes again. I'm just refreshing you guys on how to come up or determine the equation of a straight line. Y equals mx plus c, where m is the gradient, c is the y-intercept. The y-intercept is the value of y when x is 0, x-intercept is the value of x when y is 0. So to get an equation in the form y is mx plus c, assuming you are given 2 points, say 2, 3, and maybe 6, 8. The first thing is you get the gradient given by change in y divided by change in x. This would be 8 minus 5 divided by 6 minus 2. This is 3 upon 4. Once you have the gradient, you pick either of these 2 points, because whichever point you pick, you'll end up with the same equation. So you can pick either 2, 3, or 6, 8 together with xy plus the gradient. So We have the gradient as 3 over 4. We can pick the first point 2, 3 together with x, y. Then we want to use these 2 points to compute the gradient which is known here using the formula change in y over change in x. So y minus 3 divided by x minus 2 equals 3 over 4. 4 into y minus 3 is equal to 3 into x minus 2. 4y minus 12 equals 3x minus 6. 4y equals 3x minus 6 plus 12 is plus 6. Therefore, your y here equals 3 over 4x plus 6 over 4. That is if you're given 2 points. We've now reminded ourselves how to come up with the equation. So if you have to compute a contour integral and you're told along a straight line and they do not specify the equation, then you have to know how to derive it using the formula above. So in some instances, you can be told along a straight line with the equation y equals, for instance, 4x minus 3. You already have your y, your equation of the straight line. If you don't have the equation of the straight line, then you have to derive it. So we are told 0 to 3 plus I. So you have 0, 0 and 3, 1. So we need the equation of this straight line joining 0, 0 and 3, 1. We first need the gradient. So we have our 2 points, 0, 0 and 3, 1. The gradient will be change in y divided by change in x. This is x1, y1, x2, y2. y2 minus y1 divided by x2 minus x1, or vice versa, you still get the same value. So 1 minus 0 divided by 3 minus 0, you get 1 over 3. Once you have the gradient, you have the gradient 1 over 3. Pick coordinates x, y plus one of the two coordinates. Like for instance, you can pick 0, 0 and come up with the equation. So we use these 2 points to compute the gradient using the formula change in y over change in x. So y minus 0 divided by x minus 0 should give us the gradient, but in this case, the gradient is a third. Cross multiply, you have 3y equals x. We need the equation in the form y equals mx plus c, so divide by 3. Divide by 3. And we have the equation of this straight line is y equals 1 over 3x. So once you have the equation of the straight line, our integral is having functions of both x and y, and then you have dx, dy, it's mixed up, so you don't know which limits to use. From 0, 0 to 3, 1, it's the same thing as your x varies between 0 and 3, so you can use those as the limits. Your y varies from 0 to 1. So we don't know whether we'll use the x values, that is from 0 to 3, or we'll use the y values which run from 0 to 1. So to know which limits to use, you can either convert everything in terms of x or in terms of y. I think for this particular example, we'll do both ways. We'll first write everything in terms of x, then see what we arrive at. Try write everything in terms of y and check the answer. You should always get the same answer. So you'll be at liberty to choose whether you want to write everything in terms of x or in terms of y, depending with the ease with which you'll be able to do the conversion. And this is what you use. You'll use that equation. So use the equation of the straight line if it's provided. If it's not provided, you derive it. Use that equation. If it's a parabola, the equation will be specified. You can be told, for instance, y is equal to x squared. So you check whether you want to write x in terms of y or y in terms of x. So let's deal with this first. We can, I think we can first write everything in terms of x. Therefore, whenever you see a y, replace it with a third x. If y is equal to a third x, then dy will be equal to a third dx. Should be easy to see. So go back to your integration. And if you're writing everything in terms of x, then that means the limits will be 0 to 3. We use the limits of x. If you write everything in terms of y, then the limits of integration will be the values of y. So you use the limits 0 to 1. So first, let's write everything in terms of x. In place of x, substitute with a third y. In place of y, substitute with a third x. Anywhere you see a dy, replace it with a third dx. Maybe I can write it back. We had to evaluate this x squared minus y squared dx minus the integral 2xy dy, contour integral, plus I times the integral 2xy dx, but the I is affecting everything, so plus the integral x squared minus y squared dy. But we want to use y a third x. We want to use a third x in place of y and a third dx in place of x. And therefore, and then insert the limits of integration. So this is equal to, we integrate, everything is running from 0 to 3 because we're using the x values. So this is x squared minus y squared. Our y is a third x, the whole thing squared, minus, we integrate from 0 to 3, 2xy dy. Oh, this is dx minus a third x dx, minus the integral 2xy, our y is a third x, times dy, our dy is a third dx. Those are the first two integrals, plus an I hope I'm not too fast, into, we integrate from 0 to 3, two xy dx. 2x, our y is a third x, so this is dx, plus we integrate from 0 to 3. Finally, we had x squared minus y squared dy. So x squared minus y is a third x. So a third x squared. dy is a third dx. So once you have this, you only need to simplify a bit, or you can choose to go ahead and just integrate the way it is, however you please. Insert the limits of integration. So for the first part, we have x squared minus 1 over 3x squared. If you square that, you get 1 over 9x squared. Maybe I can just do everything step by step. I don't want anybody to get lost. So this is 0 to 3. X squared minus x squared over 9 dx minus 2x times 1 over 3x will be 2x squared over 3 times a third. So this is 9. 2x squared over 9 dx plus I times 2x times a third, we have 2 over 3 x squared dx. This I is affecting another term here, plus, what do we have here? Are you guys following? Maybe I've just been talking to myself the whole time. Can't tell. Online is crazy. Calvin, have you been following? Is Calvin in class today? Are you guys in class?
We have x squared over 3 dx minus x squared over 9 dx.
X squared over 3 dx minus x squared over 9 dx. To integrate this,
Excuse me, it's supposed to be s squared over 27, not s squared over 9.
Yes, it should be over 27. Sorry.
yeah, this one, because it's a third x squared, so 1 over 9 times a third, x squared over 27. So this is minus x squared over 27 dx. So let's integrate this. We'll have x cubed over 3 minus x cubed over 27. You can insert the limits later because everything is running from 0 to 3, minus 2x cubed over 27 plus I into 2x cubed over 9 plus x cubed over 9 minus x cubed divided by 81. 27 by 3. Then we insert the limits from 0 to 3. So we'll only evaluate the upper limit because everything else will be 0 for the lower limit. So 3 cubed is 27 divided by 3 minus 3 cubed is 27 divided by 27 minus 2 by 27 is 54 divided by 27 plus I into 2 by 27, 54 divided by 9 plus 27 divided by 9 minus 27 divided by 81. 27 over 3 is 9. So this is 9 minus 1 minus 2 plus I into, what do we have? 9 minus 1 minus 2 is 6 plus I times 81 over 9 minus 27 over 81.
26 over 3.
26 over 3. So you get the answer as 6 plus 26 over 3i. Let's put everything in terms of y and check whether we'll arrive at the same answer. We should be able to get this. So if you put everything in terms of y, you go back to your equation. Our equation of the straight line was y equals a third x. Okay, maybe I should specify that we're now putting everything in terms of y, because you need to choose whether you want to write everything in terms of x or y, then choose the appropriate limits. In terms of y, let me just do this. I want people to have clear notes. Shouldn't blame it on me. Putting everything in terms of y. So our y was equal to a third x. So we want to write x in terms of y. From here, if we cross multiply, then you have 3y equals x, or x is equal to 3y. So in place of x, substitute with 3y. Then we now need dx in terms of dy. dx will be equal to 3 dy. So we go back to integral. In place of x, substitute with 3y. In place of dx, substitute 3 dy. Then here everything will be in terms of y, and therefore the limits of integration are the values of y, and y was ranging between 0 and 1. So we'll be integrating from 0 to 1. Yeah, we go back to our equation. We had to integrate. I don't think there's need to rewrite the whole thing. We can just do the substitutions in the interest of time. So you have the equation with you. So we're integrating from 0 to 1. We had x squared minus y squared. So in place of x, we substitute 3y. So 3y squared minus y squared. We had a dx here, but dx is the same as 3 dy. Minus, we had 2xy. So 2 times x is 3y times y dy. Plus an I that affects the second part. So integration from 0 to 1. This is 0 to 1. Integration from 0 to 1, 2xy dy. So we have, no, 2xy dx. 2 times x is 3y times y dx is 3 dy. Plus, we integrate from 0 to 1, x squared minus y squared dy. X is 3y. So x squared is 3y squared minus y squared dy is just dy. We simplify this. So you'll get the integral from 0 to 1. 3y squared is 9y squared minus y squared. The whole thing is times 3 dy minus 2 times 3y times y is 6y squared dy plus I into 6y squared times 3, 18y squared. Integration from 0 to 1, 18y squared dy. This is 0 to 1. Plus finally we have 9y squared minus y squared dy. But 9y squared minus y squared is just 8y squared. We should have also noticed that in the first part, but no problem. So this is, we simplify this, we get 8y squared. If we multiply by 3, we get 24y squared. So the first part should be, we're integrating from 0 to 1, 24y squared dy, minus we're integrating from 0 to 1, 6y squared dy, plus I into, we're integrating from 0 to 1, 18y squared dy, minus integration from 0 to 1, we have 8y squared dy. Oops. So 24y squared, if you integrate, you get 24y cubed divided by 3 minus 6y cubed over 3 plus I into 18y cubed over 3 minus 8y cubed over 3. Are we doing the right thing? Are we having the correct thing? Are you guys following?
Yes.
Do we have the correct thing? Are we missing out on anything? We must be, let me see. Are we forgetting? Okay. So we have an I into 18y squared, plus we have another 18. For the I part, we have these. So we have 18y squared dy plus,
Excuse me, there's a mistake. It's supposed to be 18y squared dy plus 8y squared dy.
plus 8y squared dy, not minus. No. Oh yeah, if we simplify the last bracket, this will give us 8y squared dy, so plus this. Plus. So we have a plus here. Then we are evaluating between 0 and 1. If we substitute the values of the limits, so this should be 24 over 3 is, this is 24 divided by 3 minus 6 divided by 3 plus I into 18 over 3 plus 8 over 3.
I think there's a term that you've left out.
Sorry?
There's a term that you've left out. Yeah, where you're supposed... the place where you've written 24y squared dy. You are also supposed to multiply the y squared, you multiply it by 3 dy.
No, we had 9y squared minus y squared times 3 dy. So 9y squared minus y squared gives you, what does it give you?
Or 8y squared. Okay.
So times 3.
Oh, fine. Okay.
I think everything should be okay now. 24 over 3 is 8, 6 over 3 is 2, plus I, 18 plus 8 is 26 over 3, 8 minus 2 is 6. So this is 6 plus 26 over 3i. So it doesn't matter whether you choose to write everything in terms of x or in terms of y, you'll arrive at the same answer. You just pick whatever enthuses you the most. Part B. Part B, we want to evaluate this integral along the curve made up of 2 line segments. One from z equals 3 to z equals 3 plus I. So you do a sketch. Z equals 0 to z equals 3. Z equals 0 to z equals 3. Insert that missing information. So from z is 0 to z is 3. This is the straight line. Then from z is 3 to 3 plus I, you are starting from 3, you're moving a unit up. So this is 3 plus I. We want to evaluate this integral first from 0 to 3. This is 0, 0. And this is 3, 0. Then from 3, 0 to 3 plus 1. So in other words, part A we were dealing with, we just moved from, let me pick a different pen. We moved from 0, 0 to 3 plus I straight. But in part B, they want us to break this so that we do it stepwise from 0, 0 to 3, 0, then from 3, 0 to 3, 1. You could say you are now splitting the curves. Instead of moving straight from 0, 0 to 3, 1, you are having curves. You can say this is curve C1, then this will be curve C2, where both are straight lines. So you'll say that integration will be the sum from C1 plus you evaluate that sum from C2. But you have to, investigate what needs to happen. If you look at curve C1, it's moving from 0, 0 to 3, 0. It's a straight line, but it's not all the time that you have to do dy dx or find change in y over change in x, because if anything, x is changing from 0 to 3, but y is 0, 0. So y is not changing. Y is equal to 0. So if y is 0, what does it tell you about the nature of dy? Dy will also be 0. If you're moving along a straight line and one point is a constant, then you don't need to go through the hard process of finding the gradient first and then determining the equation. You just look at which variable is changing and which one is not changing. The variable that is a constant means the derivative of that particular variable will be equal to 0. And therefore, in your integration, whenever there is a dy, if y is a constant, then dy will be 0. All the terms with dy will become 0. So you only deal with the other remaining two terms. If x is remaining constant but y is changing, then dx will be 0 because the derivative of a constant is equal to 0. So anywhere there's a dx, it will become 0. The integral will go to 0, and therefore you only have to evaluate terms with dy. So let's go through this example to illustrate what I'm talking about. So here we are splitting. We will evaluate the integral along C1, then plus the integral from 3, 0 to 3, 1, which is along C2. But along C1, y is equal to 0. You're moving from 0, 0 to 0, 0. So y is 0. dy is also 0. If dy is 0, then it means we're only going to concentrate with the dx, and therefore the limits of integration will be the values of x, and x is changing from 0 to 3. So 0 is less or equal to x, less or equal to 3. So you go back to your function, to your integral. So the integral was x squared minus y squared dx. Maybe we can just write it down one final time. We were supposed to evaluate these x squared minus y squared dx minus we integrate 2xy dy plus I times we integrate 2xy dx plus the I is affecting this last term, x squared minus y squared dy. So along C1, we have dy is 0 and y is also 0. So we will have, we're integrating with respect to x 0 to 3, x squared minus y squared, y is 0, so minus, maybe let me just write it as 0 squared. Some people will start asking where did the y go to? Let me show it. So dx minus 2 times x, our y is 0, our dy is also 0, plus I times 2xy dx, 2x y is 0 dx plus x squared minus y squared, x squared minus 0 squared. This is dy, our dy is 0. So clearly these two terms will go to 0. This will be 0 and this will be 0. So you only have two terms. That's for the first curve. X squared minus 0, that is just 0. So you're integrating from 0 to 3. X squared dx plus I, the integration from, but this will also become 0. 2x times 0 is 0 dx. Actually, we have three terms becoming 0. So we only left with the first term. So we integrate 0 to 3x squared dx. If you integrate x squared, you get x cubed over 3 from 0 to 3. This is 27 over 3 should be equal to 9. That's along C1. But if you split the curves, you have to sum up. So we go to the second curve along C2. Maybe I can scroll back to C2, or I can just do another sketch. We have this 0, 3, then 3, 2, 3 plus I. This was the curve C1. This is the curve C2. This is the point 3, 0. We are moving from 3, 0 to 3, 1. So along C2, we are moving from 3, 0 to 3, 1. What is changing? What is remaining constant? So 3, 0 to 3, 1. If something is a constant, then the derivative will be equal to 0. So we concentrate with the other variable. So from 3, 0 to 3, 1, what is changing? What is not changing? What's a constant? Sherry?
Y is,
Sorry?
Y is changing, X is the constant.
X is a constant, but what is it has an exact value. What is X?
X is
3.
X is 3. Dx is 0. Y is changing from 0 to 1. So you'll evaluate the integral with respect to the variable y, with the limits being 0 and 1. In place of x, replace with 3. Dx, replace it with 0. So we go back to our integral. So we will have x squared minus y squared. X is 3, so 3 squared minus y squared. But dx is 0 minus 2xy. We integrate 2 times x is 3 times our y dy plus I times, now let me just write this I down here, plus I into, we're integrating from 0 to 1, 0 to 1, 0 to 1, 2 x y dx. X is 3 times y, dx is 0, plus x squared minus y squared. X is 3, 3 squared minus y squared dy. So because of this 0, this term will go to 0. Oops, is it behaving? Yeah, that will go to 0. This will also go to 0. So 0 minus, we integrate 6y. Let me just try to write this. I hope I'm not too fast. So we have 0 minus 6y dy plus I times 9 minus y squared dy from 0 to 1. So integrate 6y, you get 6y squared over 2, that is 6y squared over 2 minus 6y squared over 2 plus I into 9y minus y cubed over 3 from 0 to 1. This is minus 3y squared plus I into 9y minus y cubed over 3. Everything is running from 0 to 1. So this gives us minus 3 plus I into 9 minus a third. What is 9 minus a third?
16 over 3.
Minus 3 plus, is it 16 over 3?
26.
I doubt. The LCM is 27. The LCM is 3. 3 by 9 is 27 minus 1, 26 over 3. So plus 26 over 3i. This is along C2. To get that integral, we need to add the integral for C1 plus that of C2. C1 we had 9, right? The integral along C1, what was the value?
9.
9. So plus the integral along C2, we have minus 3 plus 26 over 3i. What is 9 plus negative 3?
6.
So you get 6. Is it the same as the answer for part 6 plus 26 over 3i?
Yes.
We just use this example to illustrate that if you split a curve, if you had, in the case of real integrals, if you are to evaluate an integral from a to c, but you split it and have integral from a to b plus a to b to c, you will get the value as when you go straight. So in part A, we went straight. In part B, we've split. You'll always arrive at the same answer. Let me give a problem for you guys to attempt. We are proceeding for a short break so that you guys can also get to sign the attendance sheet. You have 10 minutes. Make sure you sign for yourself before you think about signing for your friend who is absent, because I'll disable the link after exactly 10 minutes and you don't want to miss out. You know, if you want to be a good Samaritan, start with yourself. Sign for yourself first. So you attempt this problem during the 10 minutes break as well as sign the attendance sheet. Evaluate the integral. Evaluating this integral, 1 plus I minus z bar dz along, unmute and speak up, please. Along the following curves connecting points z1 equals 0 and z2 equals 1 plus I. Part A, the curve is the straight line connecting z1 and z2. Part B is the parabola y equals x squared. Part C is the broken z1, z2, z3 with z3 equals 1. Have you copied the question? Do I need to scroll up or down? Let me know what to do.
Scroll up.
To what particular point? Is that okay? Here's the starting point of the question.